Alright, so we're wanting to find all the zeros of f of x equals x cubed minus 4x squared plus 3x plus 2. It's a cubic that I can't group, so I want to try to break it down to a quadratic in order to factor it or use quadratic formula. So we start off by listing all of the possible rational roots, and we got it could be positive 1, negative 1, positive 2, or negative 2. So I'm going to divide using synthetic division until I find one that works. So I'm going to start with just positive 1. And we're using synthetic division. I'm just going to have the coefficients. So I have 1 for x cubed, negative 4 for x squared, 3 for x, and 2 for the constant. So I'll bring down my first term and multiply. 1 times 1 gives me 1, and add. Negative 4 plus 1 is negative 3. Again, multiply and add. Multiply and add. I end up with a remainder of 2. In order for it to be a root or a factor, I need the remainder to be 0. So this is not a root or not a factor. X minus 1 is not a factor. 1 is not a root. So I'm going to move on. I know it can't be positive 1, so I'm going to go to negative 1. So negative 1 on the outside. Again, my coefficients on the inside. And same thing. Bring down my first term and multiply. Negative 1 times 1 is negative 1. Add. Negative 4 plus negative 1 is negative 5. Multiply. Negative 1 times negative 5 gives me positive 5. Add. Multiply. Again, I did not get a remainder of 0, so negative 1 is not a root. I'm going to cross it out. Now I'm going to go to positive 2. Set up same way, 1, negative 4, 3, and 2. Bring down my first term and multiply. Add. And multiply. 2 times negative 2 is negative 4. Add. I get negative 1. Multiply. I get negative 2. And add. I get 0. There's my remainder of 0. Yes, ma'am. Because negative 1 times negative 5 is positive 5. You good? Yeah. You got to multiply. The thing on the outside times the thing you get at the bottom. Okay? You're very welcome. All right, so back down to this one. We did end up getting 0 as my remainder, so I know that 2 is one of my roots, right? So look at what I have left. Remember that I started, my original function was x cubed. So since I found a root, then this remaining part is what's left of my function after I factor out the x minus 2. So I started with x cubed. That means that this function's been broken down into, this is 1x squared minus 2x minus 1. This is what I have left. I now have a quadratic. Okay? If it's factorable, I can factor this to find the other roots. If it's not, I can use quadratic formula, but either way, it's something that I can work with now. Is x squared minus 2x minus 1 factorable? No, right? What do I multiply together gives me negative 1? 1 and negative 1, that's it, right? What is 1 plus negative 1? Definitely not negative 2. Right? So this is not factorable, so I'm going to go ahead and I'm going to use quadratic formula to find my other roots, because that is what our main goal was, to find all the roots. I have one of them, it's a 2, and now I want to find the others. So I have quadratic formula, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So plug in my values. Negative b just means the opposite of b. So I have positive 2 plus or minus the square root of b squared minus 4 times a times c all over 2 plus 2 times a. Everyone can see that. So now just going through and simplifying. I have 2 plus or minus the square root. Negative 2 squared is 4. So I have 4. Negative 4 times 1 is negative 4. Negative 4 times negative 1 is positive 4. So I have plus 4. All over 2 times 1 is 2. So I have 2 plus or minus the square root of 8 over 2. I need to simplify the square root of 8. So think about, what do I multiply together? It gives me 8. Two times 2 times 2, we can break it up like that. So 2 plus or minus the square root of 2 times 2 times 2, right? Those are all the prime factors of 8, all over 2. It's a square root, so I need a pair for it to be able to come out. So I have 2 plus or minus. I'm pulling this pair out, so I have 2 on the outside. I have a 2 left on the inside, all over 2. I have 3 terms. They're all divisible by 2. 2 divided by 2 is 1, plus or minus. 2 square roots of 2 divided by 2. These 2's cancel out, so I get the square root of 2. And so my final answer, we were wanting to know what all the zeros or roots or x-intercepts of this function were. So we have my final answer. Put this up here so y'all can see it. I have x equals the original 2 that we found using synthetic division. That's one of my roots. I have 1 plus the square root of 2, and I have 1 minus the square root of 2. All right, so these are my 3 roots. How do I know I'm going to have 3 roots? Why I should have 3 answers, regardless if they're pretty, they're ugly, they're real, they're complex. If you look at, I'll put it back in just a second, but if you look at our original function, it was x cubed to the 3rd power, so I should have 3 roots, regardless of what they look like. So if I had x to the 5th, I should have 5 roots. Okay? Real, complex, it doesn't matter, I should have 5 total. All right?